Do you know that every element in the periodic table has a story to tell? Today, we are zooming in on a fascinating lineup, the elements of the third period, from sodium to argon. These elements display some of the most intriguing shifts in behavior, and their properties change in a predictable yet remarkable way. Want to know how sodium, the metal you find in table salt, is connected to neon light and the noble gas argon? Stick around and we'll unlock the secrets behind these periodic gradations. Now let's take a look at the elements in the third period, from sodium to argon. We have sodium with atomic number 11. Then we have magnesium with atomic number 12, followed by aluminium with atomic number 13, followed by silicon, phosphorus, sulfur, chlorine, and argon. Imagine this: one element reacts explosively with water, another shines brightly in the light above your city, and the last one stays completely inert, which means not reacting with anything. What is the connection? In today's lesson, we will explore the journey of periodic gradation from sodium to argon. We will see how their physical and chemical properties changes as we move across the periodic table. Let's get started. As you move across a period in the periodic table, the element gradually changes their properties. This is what we call periodic gradation. In the third period, we start with sodium, a highly reactive metal, and end with argon, an inert gas. Between these extremes, each element shows a steady change in properties like atomic radius, ionization energy, electronegativity, and metallic character. Let's start with atomic radius. As we move from sodium to argon, you will notice that the size of the atom decreases. Why does this happen? Well, as more protons are added to the nucleus, the electrons are pulled closer in, making the atom smaller. So while sodium has a relatively large atomic radius, argon is much more compact. For example, compare the atomic size of sodium with that of chlorine. Sodium, being on the far left of the period, has a much larger atomic radius than chlorine, which is much smaller and closer to the right end of the period.